Right, so let's get started. So today we're going to finish up the Snmp discussion. So if you remember, we talked about that last week. So I'm going to go to content here. And you guys have started that lab, correct? So you've all, are you having any problems with that lab, or is it should be straightforward, right? So today I'll go over the scripting part, which should be pretty easy. But I'll finish up the slides first. Just ask any questions. I remind you, you have exam number 2 on April 11th. Okay. All right, so it's recording. Let's go ahead and take a look at the module. So we have here Snmp. So I got through like the first half of these slides, and I'm just going to finish up the second half today, then do some Python scripting, and then we might get into some new topics depending on the time. We really just have 2 topics left, right, which are file system analysis, and we also have security, which is going to be the UFW firewall. Should be pretty easy, which is also a Linux thing. The UFW is an interface only to the IP tables. If you've ever heard of IP tables, that's the main Unix firewall, IP tables, but that's covered in another course and in this one. We may just have one more lab. Okay, so after Snmp, I'm only planning to assign probably one more homework. All right, and that gives you time, enough time, I would say, to work on project A and project B. Okay, so so this week probably no homework except for the Snmp, which is due, and then next week we'll probably do the last homework, firewalls most likely. I may leave the forensics one in Linux as a bonus points if you want to do it. Otherwise, you don't have to. But yeah, that's pretty much. And then I want to do like a special topic on Docker towards the end of the semester. That would be the very last thing. Docker is pretty. It's a thing that's becoming important. So we gotta take a look at it. All right. So yeah, so that's the idea. So let's go ahead and I've gone over the assignments. You know, it's posted here. And the Word document, that should have been pretty clear, I think. So let's just download the slides and finish up. Oops, did not mean to do that. Download the PowerPoint. So we're going to go ahead and start the document here. I need to share this. All right. So we had covered all of this, and I believe the last thing we covered was this traps, right? And now we're just going to talk a little bit more about Snmp, a little bit of the details, but really, you know, a little bit overall what's going on. So if you remember, it's a simple network management protocol. It's actually, hopefully you've seen now that it's a much more advanced approach to gathering information about computers. So whereas in the very first script, the information gathering script that you guys used at the beginning of the semester, you were only getting local variables and very few, right? Now, instead of writing a script, although you can, you use this protocol, which is much more robust to get the information. And actually also the advantage is it's no longer local, data, but the whole network. All right, so you should have a good understanding of that. So to do management tasks, Snmp uses two other protocols, which is really what we're going to talk a little bit about today. It uses the SMI, the structure. Okay, and that's not working. What is this? Oh, okay, I think I know. Here we go. All right, so everyone should be seeing the slides now. So as I said, it uses two protocols, which are SMI and also MIB, right? So the management information base, which allows you to define the variables, and then the structure of management information, SMI, which is kind of like this defines the syntax of how you can define structure, right? So this is the relationship that you have there. So we're going to look at Snmp and network management from a couple of views. So from the organizational view, the informational view, the communication view, and the functional view. So this basically indicates, the different, terms of what it does, the functions, in terms of how it communicates, that's the communication, and so on. So you can see here, if we look at organizational model, we're talking about the relationship between the network element, the agent, and the manager. So it's the relationship between that printer, that laptop, and a manager computer. Okay, it has a hierarchical structure where you will have basically a manager that's above all the other ones. Then you have the informational model, which basically uses these three things, right? So it uses the ASN1, which defines syntax, SMI, which is the structure of management information, and then finally the management information base, MIBs. These are all just separate elements from the protocol, okay? Each one is its own independent thing, and it's meant to be kind of interchangeable, right? So the protocol is not affected by what variables are going to be queried from that machine. That's the idea, and it's a good one. All right, and then you have the communication model, which has to do with basically the TCP/IP stack, how the information is being exchanged via the packets, basically, in the network. So everything, as we talked about, is basically simple packets, messages, and then even the security framework, which, as you have seen, is not very secure, basically. All right, so the organizational model, we have a two-tier organization where you basically have managers and you have agents. Okay, now keep in mind, one computer can have both an agent process and a manager process. So it doesn't really matter. What matters is processes, not computers, right? So, but usually you have a manager, and the manager can query the agents. You can have several managers, and they can query the agents as long as they've been added to the access control file, as you did in the lab. The three-tier organizational model might be if you have a manager, you have some agents, and then you have something where you have a device that's not supported by Snmp. You think of like a PLC or something, programmable logic controllers in industry. You may still want to query those and get information about them, but you won't be able to do it directly. So you need to have, a proxy server or an intermediary that allows you to do that. So basically, the idea here is that an agent for every managed node, basically. And that's where every device on your network would have Snmp agents. Objects are the variables, right, which basically describe the state of each device. Okay, so remember, everything is kind of a key value pair of an ID and a variable. Okay, and then as far as the formatting and specification, SNMP uses all of these. Okay, so this is just kind of for your information. We're not actually going to be programming this, but this is how you would build, a lot of the infrastructure. So you can think of MIBs as the main data structure, basically, for variables. Okay, and this uses SMI. All right, so this uses SMI, which is this one over here, and SMI defines SNMP data structures. Okay, so it's basically like if you want to create your own MIB, you kind of have to look at SMI and the data structures that are available. And then ASN1 is almost like the standard. It's the standard, stands for the standard object definition language, and it's basically like if you think of like the syntax that you would use to define these data structures, which are then used in the MIB. Okay, so there's a good analogy to just programming languages as well. And if we want to continue that analogy, BER is then definitely like machine code, right? So this would be the machine code, right, at the machine level. So basically bits, etc. We're not going to get into those details either, but there is for SNMP something called the basic encoding rules. And this is just how everything is encoded into, the size of the variables and then, the bits that you're using. Here's an example of the flow of SNMP. So it's SNMP information flow. So for instance, here you have a managed node, so an agent basically, right, on a device. You want to query something from it, so you're going to query a variable, which you're going to refer to as an object. And remember, these have to be instantiated, so they're really like data structures. And then you have to instantiate, or classes, and then you have to instantiate the object itself. So variables to describe the devices, right? That's the thing that you're going to need. That's going to come from the data MIB, where the MIB has the data structures of what variables are allowed. To define those data structures, that comes from the SMI. And SMI are the rules to describe objects and variables, okay, which actually use the ASN1, right, as we saw, which is the syntax. Do you guys see that? Pretty simple, right? So it's just, this is important because let's say that you work for a hardware company and you guys built an IoT device that you're going to sell to companies and you want them to monitor that. You're saying that they'll be able to monitor that. So then what do you need? You're going to need to implement the SNMP protocol, and then you're going to need to define the MIB for your own IoT device. Okay, so that's, once you define that MIB, it's a nice thing because then SNMP will just be able to reference that MIB, which is defined by all of these principles. You'd have to look at SMI, ASN1, just to make sure that you get the data structure correctly done. And then once you have all the data, you're going to send it through the network, then you're going to obviously send a sequence of bytes. So for that, you're going to use BER, or the BER rules, to convert the SMI data structures into basically a sequence of bytes. Okay, so these are just all the elements that come into play to allow for SNMP to work. All right, so we looked at the organizational model. Now we're going to look at the information model here, and just, we're going to look at SNMP from that point of view, if you will. So from this point of view of the information model, right, we have now, as I said, think of everything in the MIB, this is kind of like the MIB, think of it as a class. So you guys have done class definitions, right, in your programming classes in either Java or something, JavaScript, right? So you've done object-oriented programming, so you know how that works. You define a class, and then you create instances of that. So here we have it's kind of like a hierarchical, right? We have an object, right? And then that object will have an object type. That object type has an object identifier, which is actually an ID that we will see. And it's basically, it's associated with the syntax that it uses. And then that object actually can have multiple instances. So for instance, interfaces. So you just define one interface as a class, but then you might have on a router two, or a firewall, 2 or 3 interfaces, right? So each one of those interfaces is an instance of it, of that data structure. So object naming. So, you know, an object will have a descriptor and it'll have an object identifier. Okay. So we'll see this is important because just like with DNS, where everything is organized, right, in a tree, in a hierarchical data structure, like a tree all the way to the root, here with SNMP, we have the exact same thing. So all OIDs, which that's the object identifier, are organized in a hierarchical data structure. And we will see that in a second. So the management information base, or MIB, it's a hierarchy of information about a device. So think of an MIB as a simple database. It uniquely identifies specific information on a specific device. So every single variable, and there can be thousands of them. Okay, so you have object type, you have name, and then you have allowable operations. Okay. The structure of management information, or SMI, defines the standard unique names for objects, right? Defines standard formats for objects for use in MIB, you know, such as the length, the data type, etc. Okay, so it's more like, you know, not the syntax, but how, you know, what is allowed, right, as far as the limits of variables, etc. So here's an example of the hierarchical data structure of MIBs. So if you notice, as I said, it's a centralized approach where you can only create OIDs within this tree data structure. So every single device has to fall within this. So the root of the OID is actually this one, the internet. So that stands for 1.3.6.1. Okay, so every OID will basically start with that. Okay, and then after that, you're going to start leading into the different directions. So if it's, for instance, private OIDs, or if it's the standard management OIDs, then you go in this direction, and then this is now the different ones. So for instance, for interfaces, if I want to know the prefix of all interfaces in, you know, in the standard approach, it would be 136.1.1.2. You see that? So whenever you want to query an interface, the OID would start with this, and then after this, you know, you're gonna have an additional component depending on the specific variable that you're trying to get. Got it? So usually when you do these queries, you can imagine that underneath the SNMP protocol, it's using the OID. When we try out some Python examples, I believe I'll give you the Python script. It's pretty simple. You just have to query a few variables, but you'll have to figure out the OIDs. Okay, unless you can figure out how to make the call based on the description name, which might be possible as well. But as you might imagine, I'm going to give you a script with like one example, and then I'm going to leave to you to query multiple ones. Okay, so I'll, you know, that'll be part of the assignment, as you saw in the Word document. So the private MIB then, if you look, would be the 136.1.4. So 136.1.4. And really this is important because a lot of computing, including on the Windows side in Active Directory, pretty much all variables are organized the same way, right? There's a centralized root tree, hierarchical tree. And whenever you create a variable, you create it within this. And that's a good approach to organize things really well. Questions? Does this make sense? Yes, sir. Where's that? Oh, yeah. So no, that just means if you, let's say you're a company, like you're Cisco Systems, right? So you want to have your own OIDs for whatever reason. So then you don't go through the general approach, right? You go through the hardware, firmware specific one. So in that case, you're still going to have 1361, but now you're allowed the 4, right? And then if we go to the other one, so it's 13614, 1, and then now Cisco. You see that? You see that, Lenny? So Cisco would be 9. No, Cabletron or whatever is 52. You might imagine every company that has hardware, you might want to look up Apple, or they might have their own OIDs. Do you see that? Well, I mean the 9 here, right? This 9 is that one there. Do you see that? So you have to follow the sequence like this. Do you understand? Mm-hmm. This is again important because you need, when you query, think about how much hardware there is in the world, right? And no, Cisco is no longer the dominant router and firewalls. Let's say there's others, and so they all have OIDs, and everything is hierarchically organized. So when you query one of these variables specifically, you can query it by the specific OID, and it's nicely organized instead of chaotically. Everyone has their own thing. The idea is SNMP is meant to be a protocol, like the internet, right? The internet works, right? Browsers work for everything, more or less. And this is the same idea. All right, so the 3 parts of SNMP. So the 3 parts of SNMP, we have the protocol. The SNMP network management is based on 3 parts. We have the protocol, the SMI, and the MIB. So the protocol basically defines the format of messages exchanged by management and agents. So we have get next, set, and trap operations, which we've discussed. Then we have SMI, which are rules specifying the format used to define objects managed on the network that the SNMP protocol accesses. And then we have MIB, a map of the hierarchical order of all managed objects and how they are processed. Okay. A good analogy of this is this one, looking at SNMP and comparing it to computer programming, right? So in computer programming, you'll have the language syntax, right? And then you'll have the object's declaration and definition. And then you actually do the coding itself, right? That's kind of how we learn. You learn C, you learn the syntax of it, you learn how to do the declaration of objects, and then after that you do the programming. Well, the same thing, it's the same idea for SNMP. You have the SMI, which is like the language syntax, the MIB, which is like the objects, declarations, and definitions that you can use. These are the variables, a module basically that you can, import into your library, into your computer or a library, and then you use it in the SNMP protocol, okay? Here's an example of a workflow. So let's say that you have a manager and you have an agent, all right? And the manager has a question, number of UDP user datagrams received, right? So it wants to query this. This is the management question. So this is going to come from the manager, okay? So the manager then makes the query. To be able to make this query, though, the manager would basically need to know that the OID for this is 136121710. The object has an integer value and is called UDP in datagram. So this is the actual name, and this is the OID of it. Okay, those parameters were defined in the SMI. So this is integer values using these attributes. And then SNMP protocol would encapsulate the request in a GET request message or packet. Okay. So, you define, you have the question needs to be defined and encapsulated. And then once it's encapsulated as a packet, you send out the packet, which is going to be a GET request packet to the agent. Okay, the agent will then reply back with the response. All right, and that's the flow. And then all of this is UDP packets, basically. Okay. And then you finally have your answer. All right, so as we've said, so kind of to summarize the languages of Snmp, structure management information, SMI, so specifies the format used for defining managed objects. The ASN1, this is used to define the format of Snmp messages and managed objects, okay? Using an unambiguous data description. And then BER, which is, we're not really going to worry so much about this, but this is, almost like the machine code used to encode Snmp messages into a format suitable for transmission across the network. So the management information basis, Snmp itself does not define which information or which variables a managed system should offer, right? That's the beauty of it. So Snmp is almost like the transport mechanism, and then there's the MIBs, which are, the databases. So it just simply knows, okay, I need to query, give me the MIB, so I know how to query the variables, and that's basically the idea. Additionally, Snmp is extensible, which is great because obviously there's new hardware all the time, and Snmp was actually developed many years ago. These principles and hardware obviously is being invented constantly. So nowadays with the Internet of Things, etc., it's even more and more. Okay, in detail, the abstract syntax notation, or ASN1. It's a notation that's pretty standard and flexible, describes data structures for representing, encoding, transmitting, and decoding the data. And it's basically a set of formal rules, okay? Describes the structure of objects and how, the notation for it. Okay, so we've talked about this. And here's an example of a portion of an MIB. So you can see this is in the interfaces group. It's an implementation of the interfaces group, which is mandatory for all systems. So you can see how this would be basically the syntax and the language that you would have to follow to declare MIBs if you're creating new ones or you want to interpret some of them. So in this case, this if means interface. So the interface number, object type, then you specify that it's an integer, the access control, which is read only. The status is mandatory, and network devices have to have interfaces. There's a description that says the number of network interfaces regardless of their current state. And then you assign it to the variable, right? So interface number 1 or 2. So this is, kind of the basic idea of the encoding. Notice it's not like XML or JSON, it's just its own specific thing since it was developed a long time ago before those were developed. So variable names are aliases for digit strings within MIBs. So from the previous phase, we had an interface if number, which is interface 1, and this interface was defined in the MIB to be 1361.121.21. Okay, so in your homework assignment, this will be the challenging part where you will have to find interfaces. So I'll give some examples today that I brought, but you'll have, of some of the things that you can do. So we'll go. The code is actually pretty simple, so it should not be very extensive, but as to make it a little bit challenging, you'll have to collect some of these. So everything will revolve around getting these from Unix, obviously from your seed VM. All right, so you can see there's the architecture as the root. As I said, it's a hierarchical data structure or hierarchical tree structure. 1361. All right, and then after that, it continues with the sequence of things that you use. This would be like the domain type of what every number represents, right, for the standard. And then we've talked about this, how to declare some of these variables. Okay, so you can see examples. The basic format for a packet here is going to be that you have the message length, the message version, the community string, which is the password basically, the header, and then the body, which usually will contain the question that you're querying. So it's a simple packet structure. But the great thing about this protocol is that all of that is defined for you, so you don't have to worry about it. And I think that's actually a really, really neat thing that's available. Here are the commands in relation to an SNMP manager and SNMP agent. So remember, these are UDP connections. So from the manager, you'll have get request, get next, get bulk request, and also set. Remember that you can set values, although we kind of said to disable that one. The SNMP agents can provide responses, obviously, to the queries, and they can also generate traps. Do you guys remember what traps were? Yeah, go ahead. Yeah, so they're non-solicited, right? They come from the agent itself when something has happened. Okay, good. And then, of course, managers can talk to other managers to provide reports, information requests, etc. So there is that system to sync to managers as well. And that's it. That's the protocol itself, is pretty straightforward. Burr will skip this. I mean, I'm not going to get into the machine level. So that, you can read through it if you'd like, but, we don't need to learn about zeros and ones for this. Okay. So that was, organizational model and information model. Now we can look at the communication model and then the functional model. So here's the communication model. As we look at the OSI model, you can see you have an SNMP manager and you have an SNMP agent. Okay, and in the OSI model, notice we have the physical layer, the data link layer, the IP layer, and then it's UDP, and then that's followed by SNMP. So it's got, it's going to have an IP header, a UDP header, followed by an SNMP header, which provides the functionality at the application level. And then this is the communication across the network. Why would it be TCP? I mean, you have some packets can be TCP, some can be UDP. So no, but that's a good question. Why UDP and not TCP? What's the difference between the two?
TCP could if you're not getting the packets, keep trying to get them UDP.
Exactly. So UDP just sends a packet, and if it gets there, great. If it doesn't, yeah. So that kind of tells you that SNMP is probably not, a critical service, right? So like if you're on the internet, you want to get all your packets, right? If you're watching that movie, you want to get the whole movie, right? Not missing packets. Whereas here with SNMP, it's more about monitoring. You see that? So it's not as mission critical in the sense. You can always just query it again. Do you see my point? So that was a decision that was made. This also reduces traffic, right? Because there's fewer packets. And if you're monitoring this whole school's network, think about it. You guys are watching YouTube videos and everything, right? Or on Facebook and things like that. That's generating a lot of traffic. But SNMP running in the background, it's also taking a lot of bandwidth, correct? Could be. And so you want to make something that has a small footprint. Do you see that?
Yeah.
Make sense? All right, good question though. Any other questions, guys? So these are all just design principles when the protocol was created. We'll see, I have some historical slides at the end, and you'll see it's been around for a long time. A lot of work has been done. And as I said, companies nowadays sell you products on top of these ideas, right? Including Microsoft. I mean, it's a good business, right? There's Spiceworks. I have a friend of mine who works at Spiceworks, and he was telling me that Spiceworks provides a lot of IT help, but really what it's doing in the background, let's say all of you are IT people, right, in various companies. and you all use Spiceworks for tracking and monitoring some things, simple things, right? Well, you're interacting with that system very much like you interact with Facebook. What do you do on Facebook? You put your pictures and your notes, and Facebook takes that and learns about you, correct? Well, Spiceworks does the same. But what are they learning? They're learning about your IT practices in your company. Do you see that? And that's the value of it. Believe it or not, it's not so much the Spiceworks thing that the reports or anything. It's that they're learning all in a perfect world, they would have all IT people, at least in the United States, working on that system. And that means they know what IT people want. They know what to sell them. You see them. So all of this is pretty important. Anyway, security. So the last bit of this before the history is security. Okay. So in security, you basically saw, as you saw even in Ubuntu 2004, I think version 2 is still available, and you were using clear text passwords, right? So you can see it hasn't changed a lot. It can be used quite a bit. Since you're monitoring, right? You're not setting anything. That's kind of okay. Basically, you define communities, I guess. That was the idea originally. Specifying access to specific variable sets. It can be read, write, but you're basically focusing on read only. You supply community name as password, okay, which in our case, I think it was public. Was it public? Can't remember. Do you guys remember what it was? Yeah, public. So remember, when you see that word public, that's actually the community string. And it's unencrypted in a version of SNMP that's still widely used today. All right. This just talks about the port numbers for UDP. We talked about that a little bit, right? And those are the port numbers available. So I think I have a graph of that. No, I do. You can see it here. The client uses 162 and the server uses 161. Okay, and then it can open this port whenever it makes a request to the client, right? So that's the idea. Okay, and the final part is the functional view of the model, which basically has to do with, kind of the recap, the tasks that we have available for SNMP. So the basically, addresses it addresses configuration, fault tolerance. Remember, we're just talking about Unix here, Unix sign. So fault performance, right? So you've seen that, like you can monitor the usage over time, right? So that's the graphs that you're collecting. So how many of you have already collected some data with SNMP for CACT? Not yet? Nikita, did you? Yeah. So you're still working on the SNMP lab, I gather. Okay. All right. So you'll have to configure and collect some data. Then you have aspects of accounting, and then security, although it doesn't provide. It's not a security protocol, really. So here's the history, a little bit of SNMP. So historically speaking, let's talk a little bit about where it comes from. So Snmp Version One was the initial implementation of the Snmp protocol. It was criticized because it had very poor security, right? So authentication of clients was performed only by a community string, which was that public, and also the access control, basically, of what IDs are allowed to query what agent. In effect, a type of password, which was transmitted in clear text. SNMP was approved based on a belief that it was an interim protocol needed for taking steps toward large-scale deployment of the internet and its commercialization. So in its most general version, it was like this. Obviously, as people invest in this, as a product, usually, as I said, the two things that they will add to this, well, three things I would say is performance, right? Security, and then the ability for reports, et cetera. But just be mindful, as I said, nowadays, these companies are probably collecting that data somehow. Okay. Snmp version 1 is widely used and the de facto network management protocol. Version 2, revised version of 1, improvements in the areas of performance, security, confidentiality, and manager-to-manager communications. It introduced the get bulk, which was an efficient way of transmitting the variables. So it was an alternative to get next. So for retrieving large amounts of management data in a single request. And the new security system in SNMP was not widely accepted, was viewed to be overly complex. So again, remember that with security, as you encrypt a lot, it becomes more restrictive. Also, it can slow down the network, et cetera, because now imagine all devices now, whenever they send a packet, they have to encrypt it, right? So think about that. That means a little bit of a burden on the CPU. So all those things need to be weighed in, okay, as this was being developed. SNMP version 2 was bilingual. So bilingual between versions 1 and 2. So it can talk to older versions. To support this dual management environment, a management application in the bilingual NMS must contact an agent. Then the NMS then examines the information stored in a local database to determine whether it belongs to version 1 or 2 or some other. Version 3, SNMP version 3 provides important security features, right? So that has been the direction. So now it talks about things like integrity, authentication, right? So integrity is, if you remember from your crypto class, is hashing the packets, right, to make sure that they weren't modified. So ensure that a packet has not been tampered with in transit. Authentication means verify that the message is from a valid source through some means, right, of authentication. And then you encrypt for confidentiality. So this should say probably confidentiality, prevent snooping by unauthorized sources, right? So this would require the use of cryptography, basically. SNMP implementations vary across platform vendors, as I said. So nowadays, this will, oh yeah, go ahead. Yeah, sure. Yeah. So as I said, the original protocol is what has been out there. It has been, used, and it defines the underlying background, but this gets extended by vendors, Microsoft, et cetera. So SNMP implementations will start to vary across platform vendors. SNMP is also sometimes an added feature, not an element of the core design, right? So that can, means that it might be not as efficient, as it could be. Yeah, and as I had said before, one of the issues is that using SNMP to query certain data sets may result in high CPU utilization, and that could, put a burden on your network. Okay, so keep that in mind. If it's, that's a lot of packets, right? So it's something to consider. Security implications: SNMP versions 1 and 2 are subject to packet sniffing if they're in clear text. So all versions of SNMP are subject to brute force and dictionary attacks for guessing the community strings and authentication strings, which is true, right? If you're always, even if it was encrypted, if you're using the keyword public by default, that's, or an easy password, it's subject to brute force. Now, one important thing that we talked about is SNMP configuration. The right capabilities can be misconfigured and used to change variables. So that's something that should be avoided. So good practices with SNMP. Patch, of course, always patch your services. Disable SNMP for all systems where it is not needed, right? So that's just device hardening. Block all SNMP traffic at the site perimeter. And that way it leaves external systems like external routers the only, that they shouldn't be vulnerable, basically, okay, to this. So they should only be queried from the inside network, etc. Yeah, and so basically device hardening is the recommendation. And then here is another example of SNMP, although in your lab, you guys are using Cacti. Right? So in your lab, you guys are using the Cacti software to kind of monitor SNMP. Once you start configuring it, it'll look a little bit like this. So in this case, you notice that we have one device, host name, it's a catalyst, so it's a switch there. There's the community, the specific general OID root, right? You have the SNMP versions that you're going to use. And then this is the MIB. This is the MIB that defines a lot of the OIDs. You know, this is just some of the OIDs that are available, sorry. And you can see that, you know, such things as system description, system object ID, uptime, contact name, location, services, and so on, right? So all of these. So the idea is as a GUI, you know, website, this is, Cacti is basically a web application. So when you load it up on your browser, you can have multiple devices on there. It's going to tell you if the devices are up or down, you know, somewhere. And then it's going to list all the variables that it has available, the information about it, such as this one, you know, the system has been up for 38 days. And then also you can generate the graphs that I was talking about. These graphs basically help you to, you know, infer things, right? So the idea is monitoring, but also, you know, learning things about your networks and just being able to understand how that works. Is this clear? Pretty simple, right? So there's nothing complex about this. You can see here, there's an example of a graph, an SNMP graph over, you know, usually this axis is time. This one means if interface in octets. So it's the number of octets that went into that interface over a period of time. So here you can see that at the specific time here, you have a peak, and then you can see for some reason, maybe this is when it started collecting, but you can see it's pretty stable, for instance, for your network, except maybe for this part. So you might want to inquire as to why, especially if it was a big peak or if you had a drop, right, or something. So that's the beauty of this protocol, right? And all the tools that are available. You notice this is another tool, op utilities, that allows you to, you know, to do various things like receive traps, look at MIBs, do an SNMP walk, check the community, and so on, viewing nodes, etc. And also a few other things like ping and so on. Here's just more information. This is more information about the reports. Like I said, you know, this is where, you know, this translates into, you know, dollars, as these are, you know, enhanced products that people will commercialize for you. All right, and that's it. So you can take a look at the summary there for SNMP. Here's a little bit of everything that has been happening historically. All right, so now let's go ahead and look at some examples for the assignment. All right, so let me get my notes here. All right, so everyone should be seeing the whiteboard. All right, so you have the document for the configuration. And then we have, we'll talk about the scripting in a second. As far as the network, I should say, I guess for the lab, for this lab, you will need 2 VMs. Two VMs? Yeah, never use link phones. Go ahead. Speak. Yeah, I would just say you should always, if you're doing linked ones because of RAM usage or something, that's fine. But in general, I would just advise you always have 2 separate machines. Yes. Sorry about that. I mean, it's just, it is what it is. Okay. But anyway, definitely for this lab, just follow that NAT config. So this actually answers, the question you had. Use the same NAT configuration video that I posted for DNS. Obviously, this is no longer a DNS related lab, but the configuration still apply as I described. You'll have 2 VMs there. One should be the manager. One is the agent. Where do you configure Cacti? Here? On the manager, very good. So Cacti would be on the manager. Cacti is just basically a web application that will look like the thing that I just showed you, where you can see the machines as they're up and running. So make sure you do that, okay? So that's the configuration. We'll take a look at the code in a second. So I'll provide some. The script is pretty short, so it's not a big deal. All right. All right, so this is what I was looking for here. All right, so Snmp. So we're going to talk a little bit about the variables right now, okay? Just very briefly. So the task that I will give you is basically you have your network, right? Your 2 machines, seed and clone of seed. And then this has a manager and this has an agent, right? The agent is, let's see, the agent is what you're going to query, right? So the code, the Python code will need to be here, right, in the manager. Okay, so you're going to write a script where you're going to query some, variables from the agent, and you should be able to see them, okay? So really the code I'll provide, but you need to figure out what are the variables that you're going to query, and that includes knowing the description of each variable and the OID. Okay, so I'll just give you some ideas. Now remember, there are in general, there are basically general OIDs that every system should have, and then there are private or specific ones that belong to individual companies. Okay, but by the OID itself, you kind of know what they are, right? By the initial prefix, and then you can always just check out the MIB of it. So let's just say in terms, so we're going to talk about OIDs here. Okay, so some Snmp, so this is not on the slide, so some Snmp properties are expected to be on all systems. Are expected to be on all systems. Okay. And these are referred to as the system Snmp variables. So these are known, also known as the system Snmp variables. Okay. And these are going to be under the prefix and are under the prefix 1, 3, 6, 1, 2, 1, 1. So this is probably where you can start in your homework assignment, right? So I'm not sure how many variables I'm going to ask you to do. I'm probably thinking about 5 or 10, we'll see. But this is a good place to start. You will have to look now. If you configured your router at home with Snmp, you could query it, right? There's no reason why you can't do that, but you're only required to do this for the seed VM. So remember, this is seed, and this is clone of seed. So basically, that means you're talking about a Unix or a Linux MIB. So you're going to have to research this online to figure out, these variables basically. And it's kind of a exploration lab in that sense. Okay. All right. So some Snmp properties are expected to be on all systems, and these are also known as the system Snmp variables, which are under the prefix 1361211. So let's, for instance, let's take a look at an example here. So we have the interfaces. So that's the most popular one, obviously. As all network devices need to have interfaces. So the interfaces, Snmp variables. Variables. All right, so these are going to be these are for the interfaces. The basic interface statistics will be provided here, and the OID for it is 1361212. So because this is a hierarchical tree, this is sometimes also referred to as the OID subtree. Right? So this, this can be referred to as an OID subtree. Okay, and it's just as I said, it's everything under the prefix 1361212. This should work for your Unix operating system, and that will reference the interfaces. So you just, now the thing is, you got to figure out what statistic do you want from it. So for instance, remember in octets, out octets, that kind of thing, right? So how many bytes received, how many bytes sent out. And this usually, the description for this, the name, is IF number or interface number. So that would be the description. Got it? Is this clear? So as you start to do the homework, you can start searching for those. We talked about the Snmp walk mechanism, which basically takes an OID node as an argument and tries to discover all subnodes in it. So it's basically you know, like if you want to think of a depth first or breadth first search, right? Things that you learn in your data structures course, right? Those two algorithms, that's basically what you're going to use, you know, DFS or BFS algorithms to be able to navigate through the tree. So we're not going to do that obviously here. That's Snmp walk handles or implements that algorithm for you. This command uses the Snmp operation get next or get next in bulk, which will return all the nodes in the tree, basically, so that you can traverse to it. And it's the classic algorithm. So I should say that for Snmp walk, uses classic DFS and BFS tree searching algorithms. All right, some additional OIDs that you can explore as you do your assignment. So I'm just going to provide, you know, some hints here. These are hints for the homework to give you something at least, but you're free to find whichever one you want, as long as you need to get a result, right? That's the whole point. Now, keep in mind, some OIDs also may not have values in them, right? So please search for things that provide. So you're going to have to tell me, like, this is the code. These are the OIDs that I described. This is the description of it. Boom, I run it with Python. And by the way, here's the result. Okay, show a screenshot of it. That's all I need to see. So the possible OIDs that you can try out. You can try out could be the following. So I'm just going to give you some here. And I'm not going to tell you what they are, but you can explore that. But at least it gives you a starting point. 13612 1 2 2 1 4 1 or 4 2 or 4 3. So obviously this 4 means something, right? An entity in the MIB, and you can try them out. So you can see here. This is one, you know, these are 3 OIDs that you can try out. 1361 2 1 2 2 1 4 1 4 2 and 4 3. Another one that you can try is 1361 2 1 2 2 1 10.3 or 11.1 or 11.3. All right, so this is another set. So find out what these are, right? Find out their description, and then see if you can't query them. No questions? All right, good. Seems like it's clear. So when you're doing the Python scripting, what are the things that you're going to need? So for your scripting, you're going to need basically the IP address, obviously. You're going to need the community string. You're going to need access control, permission, let's say. And you're going to need the OIDs to query. And that's it. Right? So you need the device, let's say that printer, that's the IP, right? The community string, public, the file, the access control file in it, where you've given permission to this laptop to be a manager, and then just the OIDs that you're querying. And that's all you will need. Okay. All right, and that should be it. Now, obviously, if you wanted to automate the process, I'm not going to require this, but if you wanted to automate the process of SNMP querying your data, you could use cron, right? You could use cron entries and then just make calls to the script and collect the data. Actually, in the, if we go to the, if we go to Brightspace, this is not, I'm not going to require this, but for those of you that are interested, I always provide this as a reference. I kind of put it at the end, so it's not going to be done. SNMP and web. So this system actually is like, instead of using Cacti, you could build your own from this just by using Python. Okay, so it's got everything that you need, all the details, including the solutions, actually. So you can, you know, if you wanted to build your own Cacti system, you could do it this way. Right? You know, cron entries, what variables you're going to query, all the IPs, you know, and then, you know, and even it generates web pages from Python, and then those were going to be updated constantly. So whenever you have your website, you could actually see the performance. Okay, but that, you know, that's just kind of an example for you to take a look if you have an interest in that. Okay, so let's go back to the whiteboard. All right, and so that's the example there that I wanted to cover. Okay, so I think we are now ready. Then should now be ready to do the Python scripting. So we'll do that in a second. All right, so let's go ahead. Let's open up then the virtual machine. So we're going to start the VM here. Close this one. All right, so let's start VM. So I'm just going to start one VM. All right, I'm going to share this screen. Okay. All right, let's let it load. All right, here we go. So let's log in. Okay, so everyone should be seeing the VM now. Okay, so so we want to write a Python script, which, you know, if you remember, let's actually go to the Brightspace for a sec. On Brightspace in the SNMP document, we look at the Word doc, and there's a section. There's a section scripts, right? So which is basically bullets 35 through 39. The scripts will run with Python. First, we need to install. So you will need to install PySNMP, which, you know, you should be able to also install Python setup tools. So I would just try to install sudo apt pysnmp, see if that works. Also try pip install pysnmp, see if that works. Otherwise, just follow this approach to install snmp, right? So there's various ways of doing it. And then I just provide some one script, basically, one simple script. And then I'm going to ask you probably, yeah, just collect 5 OIDs. Does that make sense? As part of the homework, just use this code to query 5 OIDs, and you need to show evidence that it works. It can be whatever you want. I honestly don't. Doesn't matter. But just make sure you get 5. All right, so let's go ahead and also let me see. So here, let me just update. I don't get why this is not showing. All right, so let's go over here to the SNMP folder. I'm going to update the homework description. And I'm just going to say for the scripting section, select the scripting section, use Python to collect 5 OIDs. Make sense? Pretty simple, right? So just do that. Updated. So that should be updated now. For the scripting section, use Python to collect 5 OIDs. All right, so that should be clear enough, hopefully. So let's switch over to the virtual machine. Okay, we're there. I'm going to open up a terminal. Oops. Okay. Navigate to the desktop. And I'm going to navigate to 372. And now we're just going to create a script. We can call this one simple pysnmp. Simple pysnmp.py. All right, so this is going to be our script that we're going to use. We're going to need some variables here. So I'm going to do import. So I'm going to say from pysnmp dot entity dot reference 3413. You guys can try other ones. Dot one liner import something called command generator. All right, so it's an object that will allow you to create the commands that you're going to use to query the OIDs from any machine. So we're going to call CMD gen. So we're going to say, we're going to create an object, CMD gen. Notice the difference between this. This is lowercase. The library itself, right? The class, this is the object that we're going to instantiate. So CMD gen, which is going to be a CMD gen with lowercase dot command generator. command generator. All right, and then now once we have this object CMD, we can make a call to it. So I'm going to do CMD gen dot get CMD. Okay, and that's basically how it works. Then inside here, we just specify the parameters that it's going to take, and this will return several values. So it's a function that returns values, which are the things that we want to use. So we're going to have error, it returns some variables in case you have errors. So we have indication, error indication, comma, error status, comma, and error index. But more importantly, the results are going to be stored in a variable called var. In this variable, I mean, it could be any name, but we're just going to call it var bunch. So we're going to have to iterate through this. Okay. Let me make this. Okay. So we're going to do this like that. All right. So this is our function. Now inside here, we're going to specify some of the parameters. So the community string first. We use the CMD gen object dot community public, comma. We also need to specify the IP address that we're going to access. So we're going to do CMD gen dot UDP transport target, and we're going to provide basically here a tuple of the IP address and the port number. So in this case, the port number will be 161, right? As we talked about in the slides. And then the IP will be whatever your IP is. So it's going to be specific to your environment. I'm just going to provide an example, 205.215.116.11, right? So just so that you know. But this has to be specific, obviously, to your environment. Then after that, notice that I'm going to provide an example here of how to query a variable based on description. You could also query it based on OID, but I leave that to you guys. So CMD gen dot MIB variable, okay? And then now you have to specify which version of SNMP you're using for the MIB definition. So here we could say SNMP version 2. This just depends on whatever variables you decided, right? You're going to need this information, MIB. So SNMP version 2, MIB, comma, and then you're going to have system description, Yep. Okay. And you're going to specify, the first one basically, so 0. Okay. So, because you might have more there. And now you have another comma here. And finally, a couple of parameters. You're going to say lookup names. Lookup names. You're going to set that to true. And you're going to set lookup values. Also set to true. And that should be it. All right, so that should be all that you need to define for this to work. So as you can see, you just set up the command generator. You specify the parameters, some flags of what it needs to look up, look up by name, look up by values, and then that should be all you need. So let me save this. I don't lose it. Now, of course, this just gets the results. We still want to print them out. And that's the last part. So now you might have some errors, right? In the error indication and error status. So if you do have those, you probably want to view them just to kind of for debugging purposes. So I'm going to just put in a comment here that says, check for errors and print out results. Okay, so check for errors and print out results. So you're going to say if error indication, that means if it's not null, right? Then 1, 2, 3, 4, you're going to print out what error indication is. Just to view it, right? So for debugging. Elif 1, 2, 3, 4. Or actually, elif error status, if this is also not null, then you're going to print out that one. 1, 2, 3, 4. So print. And you're going to print out here error status. Okay. And finally, if there are no errors, hopefully, then you would actually print out the results that are contained in the varbinds variable. So this one would contain the results of your query. So this is actually the Snmp value given the Snmp OID that you just queried. So now you can go ahead and do else 1, 2, 3, 4 for name. And this is key value pair. So for name val in varbinds 4, 1, 2, 3, 4, and now you're going to print out the results, right? So you're iterating through it. So you can say, for instance, here in the print statement, we can put in a couple of format strings, s equal %s, percentage, and then you're going to just print out basically the values. So it's going to be name, comma, val. Got it? And that's it. That's your script. So you can use this one to perform the assignment. So any questions about this code? No questions? All right. So I'm saving it just to make sure I have no issues. All right. So we'll do a test in a sec. So weird. So that concludes our Snmp discussion, basically. This is the last lecture related to Snmp, and we'll be able to move on to the next topic. Questions? Nope. All right. So I believe I had configured this machine for Snmp walks. Yeah. So that's available. So then that means that the script, I'm going to change this to my local host, right? 127.0.1. All right. So I should be able to query this one. So I'm going to do Control X, Python 3. And of course, I don't have PySNMP. So I wonder if I can just do a pip install PySNMP. That may not. Oh. Good. So that seems like a good sign. Nope. Huh? Yours did it? Yeah, mine did too. Did you run the script though? Okay. So my object says that it doesn't have community. This is spelled correctly, right? Community, normal spellings. Oh, yeah, sorry about that. Should be community data. Okay, so make a note of that in the code. Go in and change that CMD gen community data. Got it? You see where I made a mistake? All right, so we're going to try it again. X, Y. You see that it worked? How do you know that it worked? What's the thing that I queried? System description, right? And what's the system description? Ubuntu 2004. Linux VM. Notice that it gives me the OID over here and the actual description. Now you just have to do 5 of these for your home. But you have code that works. All right. So that, as I said, that concludes. Usually in the past, I used to do this a little bit more with that thing I showed you where you had to build your own cacti, but you can take a look at it. I think this is good enough for this semester. All right, so that, as I said, that concludes the SNMP assignment. The 3 topics roughly that we have left this semester. Well, it's going to be the security part of the UFW firewall in Linux, file system analysis, and Docker. Yeah, so somebody's asking me to go back to the code. So I'll bring it up. And this is the whole piece of code. So this is all being recorded also, so you can just get it from the video. What was it? What was it? There it is. You see it? So that, nowadays there's a lot of ways of installing things in Python. So pip install PySNMP did the job for me. And then there's the code for those of you that want the code. And that's it. So this assignment should be, SNMP is a big topic, but it's so mature, right, as a topic, because it's been around for so long that you have the protocols, you have tools like cacti, you have libraries like PySNMP, which are pretty robust. And so, there should not be any issues. And then as far as configuration of the network, follow the NAT configuration that you use for the DNS lab. All right, that's all from me. So I'm going to go ahead now and stop the recording.